Alright, so in this lesson we're going to introduce what exactly is a fraction, and we can see a fraction it can be one of two things. First of all, we can have a fraction which turns out to be a whole number. So if I was to, for example, do this as a fraction, let's just say 8 divided by 4. Then we know that 8 divided by 4 is equal to 2, but this is also what we know as this here is a fraction, and a fraction can also work out to be a whole number. But when we mostly look at fractions, we're looking at a fraction in terms of it being part of a whole. So, for example, if we had 1/4, we have a whole is 4 parts, and we have 1 part of the whole. A whole might be an object, a collection of objects, or a section on a number line. We're going to look at number lines in a second. If we're dividing a whole into parts, each of the parts must be of equal size. Well, it makes sense. If we were to have a pie, and we were to cut that pie into 4 pieces, then each part is going to be equal. So this here would, of course, be 1/4, and I'm sure you guys all know that already. But what happens is that in order to have a fraction, we need to have two things. We need to have the top number is called the numerator, and the bottom number is called the denominator. So, for example, I'm going to give you a few. We've got 4/7. Here is the numerator, and the bottom number is the denominator. So these are some of the key terms you need to know. So you need to, first of all, know the difference between a numerator and a denominator. The second thing that you need to know is that fractions come in various forms. So if I was to have a look down here, we've got proper fractions where the numerator is less than the denominator. So these things are proper fractions. So we have 3 parts out of 10. That's a proper fraction because the numerator is less. 3 is less than 10. We have 5 is less than 6. So these are what we know as proper fractions. And of course 7 is less than 8. So these things here are proper fractions. The improper fractions are where the numerator is greater than or equal to the denominator. Now if it's equal to the denominator though, then it's just one whole, isn't it? So if we were to have, say, 4/4, we wouldn't write that as a fraction because 4/4 is equal to 1. Okay, so, but in this case, let's have a look at these. We can actually write these as 3/2 is the same as 1.5. Or we could treat it as though it's equal to a whole plus a half, which is then going to be equal to 1.5. And these things here are known as mixed numbers. So we have 3 different types of fractions. Number 1, we have a proper fraction in which the numerator is smaller than the denominator. We have improper fractions where the numerator is greater than or equal to the denominator. And thirdly, we have mixed numbers, which are a whole number, and then we have parts of a fraction. So 34 2/7, 2 5/6, 1.5. So these are, you need to know that there's 3 different types of fractions, and finally, what is the numerator and the denominator? So when we're looking at fractions, we're looking at parts of a whole, and of course we can have one whole being, for example, 1 is the same as 4/4, 4 parts out of 4, it's the same as 8 out of 8, it's the same as 16 out of 16. But we tend to look at, say, if we're looking at 17 over 4, then we actually have to divide this here. We have to divide 17 in 4 parts. So what we do, if we divide 17 by 4, we know that we have 4 with a remainder of 1. Now, considering that we're looking in parts of 4 here, then we can also write that as 17 over 4 is the same as 4 and 1/4. Okay, so this here is an improper fraction because the numerator is greater. And this here is a mixed number, which is a combination of whole numbers and fractions, in which the mixed number, this thing here, this is a proper fraction because the numerator is lower than the denominator. Okay, so now that we've actually covered some of the terminology behind fractions, let's go have a look at an example of how we can use fractions and finding we're going to do this example here. How many smileys are there in 4/5 of this collection? Well, first of all, you have to count how many there are in a whole. So in this case, we need to count the smiley faces. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15 parts to a whole. Now in this case we're looking for 4/5. So if we were to divide this 15 into 5, then we know that we've got 3 smiley faces is 1 part of 5 parts. So let's say we now have 3 smiley faces, so 4/5 of this, so let's split this up into 1, that's 1 part, that's 2 parts, 3 parts, 4 parts, and 5 parts. So what we've now worked out is that if we were splitting this up into 5, then each part is going to be equal to 3 smiley faces. So in 3 smiley faces, or 4/5 of this, we've got this one here, 2, 3, 4. That's going to be equivalent to 12 out of 15. So when we're looking at fractions, we might see 2 fractions like 4 over 5 and we see 12 over 15. These things are equivalent. And how can we tell if something's equivalent? Well, if they're equal, then we must multiply this numerator by a given number, which obviously gives 12. And if we multiply 5 by 3, we must do exactly the same to the top and bottom, otherwise they're not equal. So therefore, 4 over 5 is the same as 4 times 3, which is 12, over 5 times 3, which is 15. So we're going to look at equivalent fractions. And in order to do that, we simply just need to multiply by any number. So 4/5 is also equivalent. We're going to multiply this by 5, the top by 5, and the bottom by 5. And we're going to have 20 over 25 is also the same as 4 over 5. So we're going to look at equivalent fractions, and I guess we'll get to that a little bit later. So first of all, just to recap. First of all, what is a fraction? It's a number used to show parts of a whole, 3/5, 1/2, whatever. A whole object, though, can be a fraction. So if we've got 8 over 4, then that is equal to 2. So you would always, when simplifying fractions, you would always use the whole number if you can. If we're dividing fractions into parts to show a fraction, each of the parts must be of equal size. So if we were to split up this rectangle into 3, then there's no point having this here. This would give us a half, but clearly if we were to break it up into 3, we would need to break it up into 3 even parts. So let's just say there, and let's just assume that those are equal. So whenever we're looking at each one of these parts is exactly the same.